Biconditional statements, if and only if, with the notation statement P, if and only if statement Q. P and Q can be swapped. For the biconditional statements, the result going to be the same. The truth value for this is going to be true only when the component statements have the same value. As you see on the table, for the two symbol statements PQ, we have four combinations as true, 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 false, false, true, false, false. With the connective if and only if both of them have exactly the same value, the result going to be true. The case that both of them true, the result is true. Both of them false, the result going to be true. If they are different, the result going to be false. For this example, we're going to construct the truth table for the compound statement P then Q, if and only if the compound statement not P or Q. And this main method it is a tautology. As the compound statement provided, the main connective is if and only if, or the two head arrows here. And the group on the left, the group on the right, there are also the compound statements that what we have to get the truth value first before we do the final connective, which is the connective if and only if. This involving both like two simple statements P and Q. We're going to have four combinations. The first two columns are set as the default. The first column that we're going to construct going to be the column for P then Q. So I'm going to make a list again. How many columns are we going to need? First of all, we need P then Q. Next, we're going to need which P then Q going to give us the compound statement on the left side of the two head arrow. Move on to the right compound statement, the not P, that what we're going to need to construct. And then another column for not P or Q. This will give the compound statement on the right side of the if and only if. Now we have both left and right parts of the if and only if. The last column going to be the column that give us the result, which is the if and only if of the quantity, the statement P then Q, if and only if statement not P or Q. So we need 1, 2, 3, 4 more columns. For P then Q, recall if then. The if then true then false gonna give us false. Otherwise gonna give true value. We look at the left as the true then true. The result gonna be true. True then false. This is the case. It's gonna return the false statement. False then true gonna be true. False then false gonna be true. First one is done. Next, the column for not P, which is the opposite truth value of the P. True, true, false, false now becomes false, false, true, true. And number 3, the next column, going to be column for the compound statement on the right side of if and only if, which is the column for not P or Q. Not P was this construct. How about the Q? Q is the second column. For our convenience, you can pretend that you create another one, the small one here, which is the column for the Q. Just copy the column for the Q that has the truth value true, false, and connect these two with the OR. The OR. Recall for the OR, only both of them false, like false or false, the answer gonna be false. Otherwise, the truth value gonna be true. From the column of not P and the column Q, false or true, the result gonna be true. False or false, this is the case that's gonna give us false. True or true, gonna be true. True or false, gonna be true. Next one, we're gonna put them together as the compound statement on the left side and compound statement on the right side of the if and only if connective. The left side, the P then Q, which is the one in gray here, and not P or Q, not P or Q, the one that we just derived. We're gonna connect them with the if and only if. For the if and only if, the observation for the truth value is both of them have to be the same, like true if and only if true. The answer or the result gonna be true. False if and only if false. The result gonna be true. So as long as they have the same true value, the result gonna be true. So when we look at the two columns that I highlighted here, if they look the same, the result for the biconditional gonna be true. The first combination, yes, true, true, yes, the result gonna be true. Next, false, false, yes, true, 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 true. It ended up like they all are true. If they all are true, so we can say this is a tautology compound statement, or we make a note here. So these compound statements, this compound statement is a tautology.